Alright, time for another draftphysics.com. Debatephysics.com also, but debate is hard to find. Hard to find rational counter arguments for any of the points raised in any of these videos. So this is a part 2 video, a video titled I did the double slit experiment at home. It's not the double slit experiment, so it is kind of just a big fraud and a fake and a phony. It's the typical, idiocracy in operation. Propaganda everywhere. Fake news. It's fake physics. Fake science. Fake, 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 fake. So, picking up where we left off, I'll just point that out in a little more clarity based on what was explained and drawn in the previous video. So the first thing drawn is the fact that the double slit experiment, the real double slit pattern, has this obvious defect in it where there's no light in these locations, and those locations continue. So you have two patterns. You have these little bars, and then you have this other pattern that is invoking bars again of a completely different size ratio. And I explained how that can be perfectly understood if you understand the slit experiments as source experiments, as surface experiments. And though the single slit would be the two surface experiment, the single impediment would be the two surface experiment. The math verifies that those outcomes are almost identical. And the double slit would obviously be the four source experiment, that you'd have to configure on all four sources. And what means why it isn't just two double slit experiments superimposed on, two single slits just superimposed on each other, and just some obvious twice as much light, but it's all in the same location, is because what you're really doing is creating a change in the surfaces. You're making a new surface that's way out here and way out here. They're very far apart, and you could just draw a line from here to here, and then a line from this surface to this surface, and all of those little wavelength differences in the length of those two lines would tell you exactly how many of these little spots you're going to have in the 180-degree arc. So the simple way to know exactly how many there are is just take the distance between the two furthest surfaces, divide the wavelength of the light into it, and it'll tell you exactly how many of these would fit on a 180-degree arc. Regular physics doesn't tell you that because it's not consistent with wave theory. It doesn't prove wave theory. Okay, it proves this vector theory. So anyway, fact, just a fact. All right. So I went through the fact that you can't understand as a particle theory if you understand that photons really aren't a clump. They aren't a one object. They're actually made up of the stuff at the Planck constant, the little quantum of energy. So the whole origins of quantum mechanics is the idea that energy comes in these little discrete Planck constant values, and that those little discrete values are in fact what a photon is made out of. But it takes more than one to make a frequency, as you could obviously understand. A gigantic wave of light, miles long, doesn't make any sense. Neither does a clump of light, miles long. But sending a signal that's timed at the speed of light, that basically duplicates that wavelength, makes perfect sense. That what you're really sending is little bits of Morse code. And if you send the same Morse code to two locations out of phase, the guy listening to the Morse code isn't going to be able to receive it. So I think I'll explain a couple of radar experiments that again demonstrate that nothing happens in here, in this space. Everything happens at the antenna, the receiver. And that's what I pointed out as a flaw in her video, where she puts smoke in this field and then says, look, it's the same pattern. Well, yes, of course it's the same pattern, because all the smoke does is change where you're receiving the photon. It doesn't show you how the photon was created at that location. It just shows you that at that location you'll receive you'll either be in phase or out of phase. There'll either be a photon or there won't be a photon. And those numbers don't change. Those lines through space don't change. Alright, so that's enough of that was part one. So let's go to where we left off, and then I'll, get to it. Alright, so where we left off was where she was making the assertion that, you can have a two-slit experiment, and you can have one side open. So I open one side, and I produce an image. That would be the top image. So all the light is going one way. More light is deflecting this way than is deflecting this way. And that's what you see in that top image. And she's picking a location and saying, see, there's light there. Well, there isn't much light there. Okay, so that's clear. It's not really pointing at any specific place that seems very bright. But anyway, and then she says, all right, let's open the other side. So we're opening the other surface. So you have two openings. You had one of them closed and only one open. And now you're going to open another one and you're going to make light disappear. Okay. And clearly that's not what this image is. The image is so poor and so bad. This is not a proof of that happening. I mean, it's just not. Because exposure tricks would make this impossible to detect that tiny number of photons difference between those two locations, because the brightness of the light right next to it is washing out your capacity to see it. So, I mean, exposure tricks are a known thing. You just turn the dial and you change the exposure of the picture and you can make stuff appear and disappear. It's really not hard to do. Alright, so it's just not, it's not good evidence. And again, it doesn't really prove anything, because I can do a radar experiment where the two signals don't ever even come in contact with each other. They don't wave into each other and interfere with each other in space. I can have them come from opposite directions and they'll still jam the signal. There'll be no light at the surface. There'll be no signal at certain locations. And it's kind of a fact that you can figure out that, well, it has nothing to do. The two signals couldn't have interfered with each other in space because they're coming from opposite directions and hitting an antenna. So how did they do it? Okay, well, they did it because it doesn't happen until you get to the surface. The surface creates the photon. The surface makes it possible for the event to take place that's a photon. A photon isn't just a blob of energy hitting something, the end. That's what the frequency means. The frequency means it's more than one event that takes place that's identified by your body and by other instruments as a photon. That's what the evidence indicates, and this is clearly, as stated, is just it's garbage as evidence. It can't be taken seriously as a proof of anything or a good reason to believe. Alright. An extraordinary claim, which is photons, a force, is interfering with another force, because forces don't do that. Ever. Anywhere. Yes. Alright, so we'll do some preliminary drawing just to emphasize some points. So this is about the double slit experiment, which creates a very different pattern from the single slit. But it's good to understand why the single slit does what it does, okay? And it does have a distinctive feature, which is this double-sized, okay, center initial maxima. Okay, it's twice as big. Now, physics doesn't explain why that happens, but the explanation is kind of simple if you just think of the surfaces, okay, as point sources. So whether I make this an impediment, like this is a solid wall, or I make this an opening, what you're really just saying is there's a distance between two sources of light, two sources of photon. And you could understand that if it was just scatter, okay, now you can make this a wave, but if there was just scatter at the surface, okay, you could understand that there's a 50-50 chance, if I'm sending a little Morse code signal here, there's a 50-50 chance that that signal, okay, at any location would be in phase or out of phase. Here it'll be out of phase, here it'll be out of phase, here it'll be out of phase, here it'll be out of phase. All right, now they often draw this little line going from here to here and say, look, the center has to be an on, because look, the two sources is going to be the same exact distance to this center point. Well, yes, but that happens inside. The distance between these 2 point sources is 1 millimeter, and that never changes. So everything inside of those two sources, everything that happens inside of them never gets bigger than 1 millimeter. And here on the target, you're talking about this distance being maybe 6 inches. So 1 millimeter and 6 inches doesn't add up to much. That's this little tiny line. So that wouldn't mean much for the rest of this. So what's the the simple answer is, as I stated, if you think about the 2 point sources and you think about that the fact is they're on a distance arc. Okay, there's an arc that they're going to be projected onto. And then you have your 2 lines. You can understand that the difference between these 2 lines is the full number of wavelengths. So if there's 20 or 30 or 500, they're all right in here. And this one is really telling you, okay, whether it's a on, starts with an on, or starts with an off, is going to be critical, right? So if this is, if this one is, 15, and this one's going to be 15 and a half, okay, then you know, oh, they're not going to be in phase. They're going to be a half a wavelength off. And so here would actually be an off, no light. And the first node would be here. And the nodes will get smaller. So this is another fact. It's just it's a fact of the geometry of spheres and circles, that they get a little bigger as you go around. So you can't just divide the number in and do the simplest thing. But it is this simple. The number of notches here tells you exactly how many nodes you'll create. And you can sort of understand that both of these are 2 separate experiments, this one and this one. And that what's really happening here in the center is that the 2 are merged. So this node, the node size here and the node size here, which would say if this was a 3 and this was a 3, then you'd end up with 5 here because they're overlapping. If this was a 2 and this was a 2, well, you'd end up with, what would you end up with? You have to end up with an odd number, 3, because you have the 2 are merging into the total of 3. So you always end up with an odd number. And I go to 4 and 4, and you're going to end up with 7, because the 4 and 4 will overlap, and you'll end up with 7. So it works out perfect, but they'll never tell you that. So the scientists, the physicists, the experts, the people with doctorate degrees haven't done this. They haven't realized it's this simple. These are just, vectors. They keep talking about the vectors. They draw the actual triangles, right? They draw you the triangles, all right? And they don't even get it that, oh yeah, well, we know exactly how many nodes there has to be because we can do it based on the distance between the surfaces. So obviously in the double slit you have you have 4 surfaces, all right? And obviously there's a huge difference between this surface, the 2 surfaces far away are making the little nodes, and the 2 surfaces closest to each other are deciding the envelope, the size of these nodes. So you have a bunch of little, the 2 slit has a bunch of little lines in the single slit pattern. And that's the truth. Those are the facts that they have ignored, that they don't pay attention to, that they don't explore, that they don't think about, because they want to prove a wave theory. They don't want to think about it as a signal, as a photon being a frequency, in terms of it being a collection of objects traveling through space. They want to believe in some wooey field thingy. Okay. All right. So maybe I'll do a really quick radar one. All right. So they often use radio as a way of verifying this. Radio photon, same difference. And so the idea would be is that instead of breaking a single signal, you're going to create 2 equal signals from 2 sources, and you're going to create your radar waves. Well, the trick is the 2-source experiment doesn't create the double slit pattern. That is, it doesn't create this pattern. All right, it doesn't create the these big empty spots. Alright, all it creates is this pattern. Okay, it just creates the single slit part of it. It doesn't do the double slit part of it. So even though it's two waves, just like the double slit, it doesn't create the double slit pattern. Alright, and then the simple argument is if I just move this source over to this other side, okay, and so instead of the source being side by side, I move this source over here and do the same thing. And so I have one source against one source. The fact is I'll get exactly the same pattern. Okay, it won't change anything. So these things don't need to interfere with each other. They don't need to bang into each other. Nothing happens in this space at all. It happens at the target. The target is where these two signals will jam each other or not jam each other. That is, the signal will be in phase or it'll be out of phase. It'll be receivable by the receiver, or it won't be receivable because there'll be two signals. If they're out of phase, the receiver can't figure out which one to pick, okay, because it's seeing this, right? It's seeing a bunch of stuff. It can't tell that, oh, this one sent this one and this one sent this one. So unless I use a directional antenna and block out the other signal, I have no chance of deciphering this mush. Okay, because the two signals are overlapping and creating a new signal that it's not set to receive. Alright, so it's kind of the argument's that simple. Again, you put all these experiments together, they demonstrate this is not about some sort of Copenhagen wave function superposition thing that are interfering with each other in space and then producing a something or nothing at the target. The fact is, it happens at the target. The target creates the photon. The photon isn't a photon until it hits the target with the right pattern. The target deciphers the signal. That's where the photon is made or not made. The same energy hits all locations. It's just in some points, just like the radar hits all locations. It's just at some points the signal's in phase, at some points the signal's out of phase, and if it's out of phase, it isn't going to be seen as a signal. It's not going to be received. The energy's still vibrating the antenna. So that's context. Those are real facts. Okay, that's the real context that needs to be explained. I could add all of the photoelectric experiments and all the other experiments that demonstrate that photons have to be understood as quantized bits of momentum. They can't be understood as waves propagating through space and expanding and going to all locations, but somehow only creating a photon in certain locations by some sort of probability math. All of that stuff is mush. Okay, it's nonsense. If you add up all the facts, they point to a simple thing, that the photon is a signal. It's an event. ... It's a piece of code. The code has to be received to be a photon. If the code is broken, if pieces are missing, if pieces are in the wrong order, it's no longer ... isn't the same as ... Alright, so continuing with the video. Now she's really not going to say anything new. These are her two shots. Putting smoke in the way, which is just making more targets for the photon to land on, not going to show you anything. It'll show you the same thing as me just moving the target screen closer and closer and closer. That's not going to show me how the photons were made. So that was nonsense. And then the other argument is this argument somehow she made photons disappear.
That spot. And when the right path is open, some of your particles will reach that spot. Oh.
Okay, so I thought this was a goofy explanation of how particles will work. There's no explanation for her diagram. So, yeah, she just paraphrases. She strawmans the particle argument. She's not arguing with anyone's particle theory. And currently in physics, you'd have to look really hard to find somebody who has a particle theory. Now, obviously, I can defend one, okay? But they're not going to pay any attention to me.
When both of them are open, It's like the particles from the right side and the particles from...
So again, drawing it her way, somehow the particles just particle, they just for no reason go in funny directions. Now obviously the argument is that a surface is not some solid piece of something. Even a piece of steel isn't just solid steel. It's atoms. The atoms are made out of protons and electrons. The protons are in a tiny, tiny location. The electrons are spread out all over the place. Obviously, when the photon, the little signal of Morse code, goes into by the surface where there's fewer atoms, less likelihood of hitting a proton, less likely of hitting a nucleus, the photon is going to interact with electrons. And it's just a known fact that the momentum of the electrons, so the electrons, let's argue, okay, let's say if you have electrons on a surface, what are they likely to be, what direction are they likely to be oscillating in? Well, you would argue in and out. They're going in and out of the surface, so they have motion in and out. The photon's coming in this way. What's going to happen? Well, yes, either you're going to move the photon this way or you're going to move the photon that way, depending on the momentum of the electron. The photon's energy, the little quanta, the little bits of the photon, hit the electron changes its direction, and as it changes its direction, it changes its oscillation from going in and out to going this way or this way. Obviously, it's pushing. Just as my hand is pushing photons towards you, it's pushing into the field, reflecting differently. This is a different reflection, right? This reflection and this reflection are different reflections. The universe changes because the electrons, you change the direction of the electron. All right, simple explanation really. One that has something to do with an atomic theory. See, they'll never draw these little balls in any context that has something to do with actual nuclear, understanding atomic theory. They do it in this buffoony way, like they might as well be dogs and cats. They don't think the small little nuclear universe is different than the big universe with trees in it. So they might as well just draw them as trees and say, look, tree theory doesn't work. Yeah, no, tree theory won't work. You have to understand what electrons and protons are, and understand what charge is, and then understand how photons interact with those charges. That the photons are actually the stuff that makes the charges repel and attract. That force is actually the force creating the phenomenon.
On the left side just happen to cancel each other out in this spot.
So yeah, same as your wave. They just happen to cancel each other out, except they don't do it in space. And the radar experiment proves that. So there is no canceling each other out. It doesn't happen. They pass right by each other, and then somehow they're not seen at the target.
Which just doesn't make sense.
Says you. So yeah. So again, it's just, look, again, this is just straw man arguments. They're not arguing with any person's actual theory, any proposed theory. They're just arguing with their straw man. So again, I could draw waves as silly things. I could be completely unfair to waves and draw them as platypuses. But that would be cheating. I don't need to. Frankly, I can defeat your wave theory without having to cheat it.
Why not? Why can't you just have the particles cancel? Well, because in this spot, they need to cancel. But just a little bit over, the particles coming from the left and from the...
It's a phase. They're in phase. They have a signal. So the argument is the particles are hitting all these locations, and the only thing you've changed is whether they're in phase or out of phase. Again, I can create the same exact pattern with jamming. Nobody thinks jamming makes signal disappear. It doesn't make the electromagnetic energy disappear. No, you're sending conflicting energy with a signal in it that's interfering with the receiver. The receiver can't see the energy. That's the argument. And the argument is that a photon causes surfaces to react. That's why you see colors from surfaces. It's because the surface is reacting. The surface is saying, I'm going to tell you what kind of photon you're going to see.
The right should happily coincide. It's like they sometimes choose to cancel and sometimes they choose.
So, of course, they don't choose to cancel. They're either in phase or out of phase at the vector location. So, again, this is such a cheat of the argument. The argument is there's a signal, a Morse code, and you can send 50-50 chance that the signal is in phase or out of phase from two locations. It's either heading towards being in phase or it's heading towards being out of phase. There's no other place for it to be. So of course it either is in phase at one location and out of phase at another location.
Not to. So, I'm sorry, Newton, but particles like yours really aren't good enough to explain.
Okay, so this is the part where, okay, it's like the gloves are off, right? I mean, I'm really allowed to say almost anything because she could put little frowny faces on Newton and pretend she's debunked Newton. Now, if Newton had the advantages that we have, okay, I mean, he had to do all his physics in the 1600s. Do you really think Newton would be any different than Einstein? And he'd be basically saying, what the hell are you people talking about? I mean, what are you doing to physics? There's no physics in your physics, okay? This is all mush. So I don't think Newton would be on your side, all right? I think Newton would be perfectly comfortable saying, yeah, everything I told you was basically true, and okay, so the photon is made of a stream of particles. Oh, gee, I have to make that distinction for you? Yeah, that's right. The particles are carrying a signal. They have to hit. There's everything about the whole universe is just screaming this word resonant. Okay, resonance. There's all kinds of oscillations, and the oscillations have to be controlled by an actual object. Okay, if you want to have an oscillator like an instrument that makes a tone, well, it has to be a certain size and it has to be a certain shape. There's obligations to have real physics, not just some fake notion that just oscillates for no reason. That's mush, okay? And Newton would have called you on your mush.
Explain how you could ever get canceling.
Okay, so again, of course you can cancel it by simply being out of phase. That's what the whole argument is. It's whether or not the signals, the pieces, are in the same phase as they were before. So you're sending two rows of dots and you're just saying, I'm going to take a dot from this one, I'm going to take a dot from this one. Well, are they an inch apart? Are the dots still the same distance apart? Well, in some locations they're going to be the same distance apart in the sense that the sequence will be the same, and in some locations the sequence will be half that distance, and then that won't be received as a photon because it's out of sequence.
Then how do waves manage to explain the double slit experiment?
So you don't explain it. That's the whole problem. So the whole argument is you're pretending to explain a double slit experiment. You're doing it with a single impediment with two surfaces. That's not the double slit. The double slit is a four-surface experiment. There are four surfaces. 1, 2, 3, 4. 4. And you're doing this and saying that's a double slit experiment. No, it isn't. It doesn't create the same pattern. It's not the same experiment. And why do you have double slit experiment in your frickin' title when you're not even anywhere close to a double slit experiment? Because you're nowhere close to a forced surface experiment. And that's what's required.
Imagine a wave is coming out of the laser. On the right side, the wave encounters the hair, and because it's an obstacle, it bends and it spreads out like...
Oh, so that's what this thing is. This is the hair, I don't know, right next to a surface? I don't even understand this at all. But again, she puts her waves next to things, okay? It's obviously the surface is causing the effect. So all the math says it's the distance between the surfaces. The math is using the geometry of the surfaces. You can't draw your wave someplace else. You have to explain how the wave is halfway on one side of the surface and halfway on the other side. That's the creation point. And you don't have any theory for a wave being created that way. That half overlaps. There's no way for you to do that.
We discussed before. On the other side, the exact same thing happens. Back in our wave pool, the black obstruction in the middle now represents the hair. And as you can see, the waves on either side do spread out.
Yeah, that's right. You can see you have created essentially a single slit pattern. You haven't created the complex double slit pattern. And it's water waves. Again, if you put the single slit in here, you'll get one wave. You'll just get one wave coming out. That's all. Make a single slit in water and the analogy completely fails. You won't get a pattern. You won't get fringes. It doesn't happen, unless you put noise into the signal. So if you make nice plain straight waves, you'll get one wave out of the single slit and you won't have any fringe pattern at all. Fact. Again, just a fact that you people ignore.
Out and they overlap. But something very surprising is happening in that overlap, and you can't really make it out in this.
Yes, you can't make anything out. The whole thing is crap. This is not, again, you're not adding value by doing these amateur duplicates of the real experiment. Again, I could create some sort of cardboard, electron gun, and buy some cheap little magnets and do, pretend I can make an accelerator in my basement. Would that really be an advancement in physics? I don't think so.
Precision setup, but it's going to be a lot more clear in the animation.
So again, yeah, the fake that we fake. Okay, yeah, look how clear it is in the fakery we just did. So the first thing missing is the double maxima. There's no double maxima. Okay, the single slit pattern creates a double maxima. It's not there. So, an obvious glaring whoops, where the hell is that? It's missing.
Where are all these lines coming from? To understand what's...
So again, this one's supposed to be twice as big. Here, right in the middle, is supposed to be twice as big. It's not there. Where is it?
Going on, imagine you're on a boat in this spot.
Then the wave coming from the left will have its peak reach you at exactly the same time as the wave coming from the right. Together, they...
and she showed them going right through each other, which again... Whoops, because obviously that doesn't happen in your theory, okay? Their superposition is exterminated once they collide. They destroy each other. So there is no anything anymore, especially in the destructive interference. But anyway.
Tend to push you up even higher. The troughs also meet you at the same time, so this spot is just really choppy. But if we instead move...
Oh, they didn't draw that part, because that would be the actual destruction of the energy.
Our boat to here, then the peak of the right wave hits exactly when the trough of the left wave hits you.
So the argument is that none of this ever happens until you actually get to the surface. And you're just measuring what's at the surface. You're not measuring what happens in space between the surface and the source. You're just saying what's at the surface. Is the surface on or off? And understand, water waves are doing this, and they're calling on, off, right? They're calling that on, when clearly that's not what photons are doing. They're not blinking at the location. So it doesn't have anything to do with the progression of a signal changing. It's either, the vectors either say that this is in phase with that, or the vector says this is not in phase with that. The two sources are either in phase at a location or out of phase at a final location. It has nothing to do with crossing each other.
The peak tries to move you upward while the trough tries to pull you down. And so in the end, they cancel out and the boat doesn't really move up or down. So this spot is surprisingly calm.
So again, it's a terrible analogy. It's not how photons work. They're not going up and down and then being neutral. Okay, it's not happening. They're not turning on and off at one location and then just being dully in between the two, like 50% at the other location. So this is a terrible analogy.
There are these choppy and calm spots all over, and if you map them out, then you get these lines.
And the lines don't duplicate what you find even in the single slit pattern with light. So even though you're kind of cheating, because we know that the single slit in water doesn't create two waves. The fact is that you don't have the right pattern. You don't have the double maxima.
What's this got to do with the double slit experiment? Well, look at
it really has nothing to do. So first off, it doesn't have anything to do with the double slit experiment, because the double slit experiment is the four-source experiment. And you're not paying any attention to that fact. You're just doing the single slit experiment in a different way, where you take the single impediment and say, look, it's a two-surface experiment. That means there's two waves. That means it's a double slit experiment. When no, it's not.
The waves across the wall.
you have these alternating parts of choppiness and calmness. That lines up suspiciously well with the pattern of the double slit, where you have...
So that's not the pattern of the double slit. So again, she just keeps... I mean, what are you going to call it? It's just such a lie. It's such an incorrect statement to say the double slit pattern looks like that, because it doesn't look like that. That's not the double slit pattern. The double slit pattern is a complex pattern where two patterns are superimposed. That's the double slit pattern. So this is just, it's just such a lie to say this is the double slit pattern. It's two patterns removed from the double slit pattern. I mean, it's like saying, somebody 4 feet tall is 6 feet tall. It's just, that's not true.
Alternating spots of light and dark.
Thomas Young's hypothesis was, when there's this waving, there's light.
Okay, so whatever. I mean, obviously Thomas Young, as explained, he's a medical doctor, did lots of research on eyes and ears. He was kind of obsessed with wave theory. Obvious comes from his own bias, and also obvious he did a shitty experiment. Okay, it's 1801. All right, the experiment was junk. There's no laser beams, there's none of that stuff. He saw little balls of light, just, he didn't even use monochromatic light, so the balls were all different colors. I mean, get real. This is not an authority. And again, if you go by Thomas Young's theory, you can't mathematically get a right answer unless you make the slits too small to create any differences. Obviously, if I make 2 point sources really close to each other, any imbecile should be able to understand I can't create any lines from those two sources where there'd be a wavelength of difference. If I make them closer than a wavelength of difference, there's no location I can go to where there's a difference in the two lines that'll be bigger than a wavelength. So obviously he just wiped out the double slit experiment by making the slits smaller, okay, than a few wavelengths. You have to have at least a few wavelengths to create some kind of pattern. So if you move the 2 point sources really close, they're going to be seen as 1 point source. They can't possibly make an out of phase condition because they can't be seen as different enough. One of them doesn't have a head start on the other. They're starting from so close a location that the signal looks like ... here. It looks like ... here too, because they're so close to each other. They have to be far enough away for this one to create ... and this one to have dots in between those dots.
And when the waves cancel out, and so there's no waving, there is no light. In other words, the amount of light produced in a spot is proportional to the amount of waving.
All right, so again, and Einstein would tell you exactly something very different, and and give you a very decent proof about why that don't work. Richard Feynman said, that don't work.
I've given this explanation to students for years, but I've never taken the whole wave picture very seriously.
Okay, so at 1 minute she said she does understand it, she did understand it, she did quantum physics and whatnot, and blah, 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 and that's just this mushy blah, 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 blah. Okay. And so now she says she understands it. She understands how you make this transverse, wobbly, wavy thing in space go in one discrete location. She understands it now. Well, I sure as fuck don't.
Yes, I knew that to make the right prediction for the double slit, you would have to use waves in your calculation.
Okay, so of course there's no waves in the calculation. So again, this is another big, giant lie. I can show me any calculation. There's no wave in any of the calculations. There's vectors, straight line, triangles they make. And they talk about sine theta. It's the angles being created between vectors. There are no waves in the mathematics. The mathematics is purely jamming geometry. It's straight line vectors. It's clearly rays. It's not waves. Ugh. And if you use Thomas Young's two waves coming out of the openings of the double slit, you will never get the right answer if you make the openings bigger than a wavelength of light. If you make the openings bigger than a wavelength of light, you will never get a correct mathematical prediction. So just keep lying.
But I thought they were just that, like just calculation tools. I didn't think that they were real. I mean, like literally in quantum mechanics, the waves are complex valued. So
Oh, so yeah, they're literally complex value. That means they must be really wavy and whoa. Because they're complex valued. That's what makes water wet, is the complex value. Don't you understand that? Water wouldn't be wet without a complex value. Shit.
instead in my head, I thought of the light as a particle when it exited the laser, and then a particle again when it got measured at the wall. But
Oh, yeah, that's brilliant. Yeah, okay. And what happened to it in between? It's a grape, and it got smushed, and then God put the grape back together and decided by probability where it landed. So he just said, whatever one gets there first. So, and the grape goes in, it breaks into 5 bazillion grapes, and all the 5 bazillion grapes are going to every location in space. But, oh yeah, there's a higher probability that the grape should land here. So all the other grapes disappear, and only this grape lands. So, yeah, so that was your theory. Something like that. Okay.
in between, it just seemed like there's nothing you could really say about the light besides a bunch of equations.
So again, and the equations all had straight line vectors in them. Straight line vectors. This distance, straight line, triangles. Which line is longer? Straight lines, not waves. Straight frickin' lines. Distances, straight distances. Point A, point B, straight line between them. No sign of a wave anywhere in the mathematics.
But this next experiment is what changed my mind and made me finally feel that the waves are actually real.
So this is going back to the beginning. So this is just doing the smoke thing. All right, so I'll explain the smoke thing really quick. But I mean, this is so, this should be like kind of even in grammar school, they sort of explain this, and this is why, this isn't going to tell you anything. This is not going to reveal the truth. You blow smoke on a laser beam, it's going to reveal the truth. It's not going to happen. All right, so we have 2 sources of stuff, and they're going to have to create a piece that's in phase from both sources, is the argument. So you're not going to see a fringe. The fringes are entirely made, okay, the stuff going out here on the side are entirely made by a necessity of this providing a component and this providing a component. You could say 1/2 of it has to come from here and 1/2 has to come from here for you to have a hole here and it turns on. Okay, so that's the idea, is that you need these 2 sources to create half the photon, right, before you have a whole photon. And if 1/2 is out of phase with the other half, then you can't make the photon. Okay, it's not in phase, it's not going to make the contribution, it won't work. All right, and that's the idea. So all the fringe pattern is made by light that didn't go straight through. It's light that was disrupted in some way. Okay, whether you believe in waves or not, it has to be disrupted. The disrupted light is the light you see in the fringes, and so that's where the disruption light hits the surface. It can't do anything unless there's a contribution from the other side that's in phase, right? So that's sort of the argument. Now, if I blow smoke, so we'll just do down. So if I have the experiment here, so I'm shooting my laser beam through here. It's getting disrupted at these surfaces, and now the theory basically is that I need a source from here and a source from here to hit at a location, okay, to create the photon. And so I can just move, okay, I can have a target this far away, and the proportions are exactly the same, right? Okay, I can have the target this close, or I can move the target here, I can move the target here. So when I blow smoke into the field of the laser, all I'm doing is moving a piece of the target here. That's all I'm doing. I'm just changing the place where these photons got hit to here instead of here. You're just hitting the photons at a different location, and where These vectors are straight lines, okay? Basically, they're actually parabolas going this way, but it doesn't really matter. They're such small parabolas, you're not going to see that unless you go very far distances. So the truth is that these are basically straight lines. So yes, you will see exactly the creation of the photon here, because the two vectors are making the photon. But you can't see the vectors. You can't see this, and you can't see this line. All you're going to see is the photon on this line. Okay, so moving the target to different locations doesn't change anything. Breaking this target into little pieces and then moving the little pieces to all these kind of different locations won't show you any different pattern, because the pattern has this geometry to it, and it's always going to look the same. So all you can do is make it look big or make it look small, right? It's big far away, it's a big giant pattern, and it's a little tiny pattern close up, but that's all you can change. You can't see these vector parts. The vectors coming from the two sources, you can't see that light because those aren't photons, okay? You can't interrupt them with they can't hit something and you see the photon, because it needs the other contribution to make the photon. Your own wave theory says this. So this is true both for a particle theory or a wave theory, that you can't see, okay, the constituent elements that make the photon on the surface. That's the whole point. You can't see them. There are wave functions. Those are the things that are superpositioned. Those are the things that are going, you know, that don't know where they are, and Heisenberging and all that kind of stuff. You can't hit them. You can't make them into photons and see them. They can only be seen if you allow both ingredients, both sources, to produce the necessary dot, dot, dot. You can't make dot, dot, dot out of just dot, or dot, dot. Dot and dot, dot won't be seen. You can only see it when it's dot, dot, dot. All right. Yeah, that's enough. Yeah, we'll just move on. Yeah. All right. So, continuing.
So I've been playing with this for a while, and I haven't been able to get this thought out of my mind. There's a beam here that leads to this middle dot. That's clearly where the light...
Right, and understand there's a whole bunch of light, peripheral light. You can see that this whole surface is lit up. Okay, so the beam is actually creating a bunch of discrete photons that are going in all kinds of locations. So it's not as simple. And the aperture of the beam is actually creating rings. You can see some of them there. It's actually creating a diffraction pattern going out, okay? It's creating a single slit pattern that's going out in all direction as rings. So there's all kinds of photons doing other things in this image besides just, okay, the slit pattern.
Light from that, for that dot is coming from, right? But what about all these other dots? Like, sure.
So the only reason why you're not seeing them in this image is because obviously the other dots are made out of the fringe light. So see how bright this little center is. So 90% of the photons, or 95% of the photons, are going right into that little spot. And the other beams are much dimmer. So that's why you can't see them, because the number of photons traveling that path is much smaller. But also it has to be understood that the reason why you're not seeing them is because they're made out of constituents coming off the laser that are spreading out this way. All you're seeing in that little dot is the light that goes straight through. All the fringes are created by light, okay, that's doing this. It's one piece is spreading way out and the other piece catches up with it. So it's one source here creating fringes this way, and then it creates fringes that way. There's always, the fringes are always pointing in the same direction. The laser beam has two sources, and they're sending the sources in the same direction, making the triangles.
Clearly that light is coming from somewhere as well. And it feels like you can almost trace back exactly where that light's from. For this one, If I follow it,
Exactly. So you're just moving the target closer and closer, and it gets smaller and smaller. This little dot on your finger will get smaller and smaller and smaller as you keep moving closer and closer to the laser beam. Yes, those places will all be the same wavelengths of difference. Okay, you'll create the same. The fact that it's going to be a wavelength out of phase or a half wavelength out of phase is decided, okay, on those trajectories, and it'll always be the same for those locations. So you're just going back through all the locations where it's in phase. But these are all new photon, new photon, new photon, new photon, new photon. You're not blocking the same photons. At each location, you're blocking different photons. You're creating a new photon at a new location. The two vectors are still happening. It's just your lines are now shorter. But there's still two vectors creating that. Misunderstand, she's still doing the single slit experiment. Okay, she's not doing the double slit.
I can go all the way back. And same for these as well.
so it feels like there should be beams kind of coming out here.
I got obsessed with this idea that you should be able to see these beams of light if you just use the right method. I tried everything, like doing the experiment at midnight for...
I mean, it's just tried everything. There's really not that many choices. I mean, obviously you want to see a beam of light. You put milk in a fish tank. You do lots of different things and you'll see the light because you're creating little bits for the light to bounce off of.
maximum contrast.
That's how you see light. You bounce it off of something. You don't see light until it hits something. So again, this is a key fact to light, that their physics is kind of breaking. But the notion is that a photon is an event that happens on a surface. It's not an event that happens anywhere else except on a surface. Surfaces create photons.
Filling a box with smoke. Then I tried filling a tub with water vapor. And I even tried submerging my laser into agar. Nothing. In the end, I caved and I bought a smoke machine from...
So, right, and there really isn't any difference between milk in a fish tank and smoke in the atmosphere, so,
a DJ shop. And I also decided to use the proper double slit so that the little bands are more...
Okay, so the proper double slit, the problem is this is so bad that you're just saying, wow, you can't get a better image than that?
more intense. And it worked.
I would love if you actually tried this experiment yourself because it's so easy to do. But I need to warn you about something. Laser
So this is the hilarious, politically correct, blah, blah, blah bullshit.
pointers are way less safe than you probably think. I bought a bunch of lasers from Amazon that all claim to be under 5 millimeters.
Look, even the moron idiocracy crowd that watches professional wrestling knows that lasers are dangerous, right? Because they had to ban them from all of these public spectacles because, they were damaging people's eyesight. It's really hard to be a human on Earth that has any kind of exposure to any kind of public function that they haven't figured out yet that, these laser pointers, stuck in your eye isn't a great idea.
Anything over that limit can permanently burn a hole in your retina. So let's compare these cheap lasers with a proper...
Alright, so they're obviously not going to burn a hole in your retina. You obviously have to get through the other parts first, but whatever.
5 milliwatt laser to see if they're safe. As you can see, this green one is definitely not okay. In general, green lasers are something I really don't recommend you buy from Amazon. Red laser pointers are better in my experience, especially little...
So again, it doesn't matter what your experience is. I just recommend you don't buy one. I don't care whether you're smarter than me and you know more about lasers. I don't care. I recommend you don't buy them.
ones like this that are advertised as like keychains or cat toys, rather than...
So you can actually just buy glasses that'll protect you fairly completely. So you just buy the appropriate glasses for the color of the light you're playing with.
like this type. But yeah, if you're going to be using a laser for presenting or experiments or playing with your cat, just make sure it isn't one that's going to burn someone's eyes out.
Anyway, it was worth buying the smoke machine. This experiment looks just magical in real life.
So it looks magical. It looks magic. It tells you nothing. Okay, so let's just understand. All she's doing is moving pieces of the target closer and closer to the source. She's reflecting places. She's creating new different places to create the photon. But it still has to be created out of two vectors you can't see in that image. There's still two vectors that are creating that photon that you're not seeing. Even by their own theory, that's a fact.
All I've done to capture it is use my phone, nothing fancy. I set the double slit up a few meters away, blocked all the lights, and turned on the smoke machine. All of these.
So yes, and obviously this image is so much better than the one she shows of the double slit. And remember how the video started, where she said, "Oh, the double slit has noise in it, and it's this, and it's that, and it's blah, blah, blah. I like the hair so much better." And clearly she's seeing the double slit pattern here, but she won't be explaining that pattern. And that's just the joke irony here, is that clearly is not in a pattern that can be explained by a two-source theory. A two-wave theory cannot explain the double slit pattern.
Beams suddenly became visible. Here you can see that there are beams of light going to all of the dots of the double slit pattern. But to see it even more clearly,
there should be a clear image here somewhere, so we'll wait for it.
Let's turn around and look toward the laser. And now, so many beams become visible. The double slit.
Okay, so you can see the dark spot. So, and there's always an odd number here. So you got 1, 2, 3, 4, 5. Guess what? You basically have 3 here, but one of them is a little too faded. So it's 5, 3, 3, 3, 3. That's what's going on. Okay, so there's two patterns. There's the double maxima, and then 3, 3, 3, 3, which is a single slit pattern. And there's these little straight lines of all the same size basically coming out. Okay, and those are what's being decided by the distance. The furthest distance is creating these little beams. The grouped beams are being created by the closest distance between two surfaces. That mathematically works. That's the explanation. And they just pretend, they just, like, she's not even going to pay any attention to it. She doesn't explain it. She doesn't even pretend to explain it.
Doesn't split the light up into two beams. It splits the light into many, many beams.
Okay, so isn't that little baby talk? Many, many beams. You know how many? Exactly how many? If you take the distance, the furthest distance between two surfaces of your double slit and merely divide the wavelength of the light into that number, it'll tell you exactly how many beams there are. Exactly. It's that simple. And what does she say? What does the doctorate of physics say? It makes many, many beams. Many, many. Yeah, that's what they say. Pathetic.
So why was this experiment such a revelation for me?
Okay, yeah, why? Because you did a trivial examination. This is just such sloppy detective work. Again, if you're going to be a physicist and bother taking science seriously, you're supposed to add value, not take value away. What you are doing is simplifying something that's much more complicated. There are many more facts, and you're ignoring all of that evidence so you can promote a silly, fucked-hearted idea.
Well, it felt like I was actually seeing the light be a wave for the first time.
Let me show you what I mean with this.
Oh yeah, I didn't see anything, the light being a wave. Did you see anything look like a wave in there? Oh, that's just so... I was actually seeing the waviness of the hard, straight lines. It's so wave-like. Hard, straight lines going from point A to point B is so reminiscent of a wave.
Laser.
I
Here
totally
you can see the
get
narrow beam
it.
of the laser, but if I put this paper in the way, a wave should spread out. And yeah, that's exactly what
Okay, and so the smoke is what's spread out, right? So we're seeing the pattern of the smoke. So now she's saying, look, I understand light wave theory because smoke is wavy. Oh, sorry. It's just too funny. I mean, this is just the normal diffraction of a laser beam will create this effect. I mean, there's light. You know, the laser beam just isn't perfect. You know, there's a lot of noise shooting off of the sides of the laser, and you can see that. But you're going to see it very unevenly in moving smoke.
The laser does. But to see it more clearly, let's add some smoke. This looks almost unreal. The laser beam is spread out, but only in this one plane, just like we...
Okay, so it's only in one plane. You know, that's, again, just more of illusion, because that's where you're looking. You're only looking at, you only can see one plane, because it's only the angles are required to come out of a certain location. But if you just change your viewpoint, you'll see it on one plane again, but it'll be a completely different plane. And then you move to another location, you'll see a completely different plane, because that's all your eye can ever do, is see one set of vectors, because you have a pupil. And I don't want to have to explain all of this, but oh, please, silly person. No, you can't see it from all the locations at once. You can't go all the way around and see it from all the different perspectives at once. That's right. But it's making light in all of those directions. It's making patterns just like this pattern in all of those directions.
Predict for a wave. If I remove the paper and put in the double slit instead, you can see the two sides of the beam.
Alright, so obviously what's happening when you put a piece of paper, a surface, right? The really simple argument, both for waves and particles, is that obviously they go this way or they go that way. They don't do this way and that way much because of the tension of the surface. So again, you could argue that if electrons were on the surface of my hand here, the theory would be is that they're more likely to be doing this than this or some other direction. They're always going to be on the surface, and they're going to be tied to the protons inside the surface. So they're likely to be moving in and out this way, not this way or this way or this way or this way. So that's why the fringes are created on a plane. The same would be true if I made a gravitational argument. The gravity would be strongest in this direction. So if I made it a magnet, the same would be true. It would tend to move the magnet this way, not this way, not that way, this way, and that way.
Interfere and cancel out. Again, just like a wave should.
Seeing this was the first time that I actually felt in my gut that light is somehow wave-like. Up until now, I just looked...
Okay, so again, what would it have to do with a wave-like? Again, just recognizing that everything that goes by a surface that you're going to contend that the surface is going to disrupt it, it has to be tied to the surface somehow. So obviously it would tend to do this, or tend to do this, more than it would do this, or this. How does a wave theory so much more obvious? That's the part, I mean, I can't understand. Why would a wave be more obvious? We know water molecules will do the same thing. They'll stick to the surface. Yeah.
The waves of quantum mechanics were abstract, and they're not. They're actually there, and you can see...
Okay, you can't see them. That's complete bullshit, so whatever. It's not in the math anywhere. There's no wave in the math. There's no wave in the image. There's no wave you revealed. It's all just a theory, and it's a bad one.
Pretty clear evidence of them.
No, it's pretty not clear evidence.
So since then I've started...
And again, you didn't explain the real pattern. So show how two-wave theory creates the double slit pattern. Show two waves mathematically creating the double slit pattern. Show that, but you can't.
Started taking the whole wave picture much more seriously. On the other hand, I've become more cautious about imagining light as particles. Photons are much more nuanced, clearly, than I thought before, and I want to try and do...
Oh, so none of that makes any sense, right? It's clearly waves, but wishy-washy.
Experiments with them as well to understand how I should be thinking of them, which is why Quantum Experiments at Home is going to be a series.
Okay, so just so bad, right? This is such a bad idea. do crappy experiments to deceive. And that's all this will create, is doing experiments to show something in a particular way so you can make your point in your argument. But it isn't the truth. It's cheating the truth. This isn't good science. It isn't good for science. Faraday wouldn't vote for this. Nobody would vote for this. But you have to be so damn careful. It's so easy to make the mistake.
I hope you have lots of questions left about light, and if you do, please leave them in the comments and we'll try and sort them out together in future episodes.
Oh, whatever. Ugh.
See you then.
Alright, so, supported by Screen Australia and YouTube through Skip Ahead Initiative, whatever the hell that is. So now it's even some other thing to worry about. Through the Skip Ahead Initiative. They don't have a logo, apparently. The Skip Ahead Initiative doesn't have a logo. So the Australian government is apparently this Screen Australia is like their version of PBS. And they have 2 logos. But the Skip Ahead Initiative, we don't know what that is. Puke. This is so depressing. This crap is running the world. Alright, so I'll read a comment just because it's too precious. Alright, so I'll go find that. Okay, I think I have found my page. So there's one comment. Just one. Yeah, so it is really just so pathetic and horrible that nobody will counter argument. Just nobody. And again, for rather popular channels, I am offering them $2,000 for a debate, or just to present my argument, in 5-minute video form, or 10 minutes of my argument, and they can debunk it or not debunk it. But yeah, it should be argued, and nobody wishes to argue any of the points raised. None of them are interesting to them. They don't care if an experiment doesn't show the double slit and claims it is the double slit. They just don't care about any of these things. These aren't important subjects. Getting the facts right, no, that doesn't matter. Oh, it's just so bad. Buddies absolutely see this is Nighthawk, whatever that means. I guess I should go find out what a Nighthawk is. Yeah, he's the man. Typical troll, right? He's probably weighs 300 pounds and eats Fritos all day. Alright, best Eka spray for rust. So he's making shorts. Oh, that's really exciting. Well, let's play it because he's in it. See what the old Nighthawk is.
Wait, there's one outside?
It's a video game. Oh, okay. So he's a gamer. Yeah. Cool. Okay. Anyway. Buddy's absolutely seething that his sleeper videos. So I don't even know what's a sleeper video. That would imply that it's like a spy video or something. Like just waiting to blow up the world. Anyway, aren't getting views. Yeah, it's kind of pointless, right, to make videos if no one's going to see the video. So yes, and especially when you're making an argument, like in politics or in some other thing, you're actually making an argument, and your argument isn't in any way responded to. Well, yeah, that's really irritating. That wouldn't irritate you? Oh, yeah, I think it would. Meanwhile, people who are genuinely excited to share their findings. So again, there's no findings here. There's just really bad experiments and silly conclusions jumped to. So jumping the evidence, it's like jumping the shark. Jumping the evidence is, for a scientist or a physicist, that's the same as jumping the shark. That is, why don't you just throw your education in the garbage? Because it's one of the first rules you shouldn't violate is jumping the evidence. I mean, it's the stupid putting the cart before the horse thing. It's not a very good steerage plan. Okay, and do so in a really well presented way. So, and that means in a trivial, childish way. So, of course, the video gamer wants everything childish and silly. He probably plays Rugrats, the video game. It's probably his favorite one, you know, squishing his diapers and such. Okay, are rightfully getting views. Okay, so it's idiocracy. So like Trump rightfully got votes, or, you know, Madam, whatever her name is, Clinton, you know, any of these morons deserved a vote. Yeah, sure they did. Oh, fuck you, idiot. Okay, it's hard not to be judgmental. That's my quote. It's hard not to draw the obviously, you know, to recognize just how trivial the world has become. That this is now called science. This trivial, hi YouTubers. Yes, pathetic. No, it's definitely not hard. Well, it is for me. It's difficult to accept that the world has gotten dumber. A lot dumber. Okay, Newton at 13 was smarter than most of you at 35. Just a fact. Okay, you just come off as an extremely conceited scientist. Well, you know, whatever you want to put in quotes is okay with me. I don't really care. The point is I'm an arguer. Okay, that's what I am. So whether I'm arguing science or I'm arguing something else, I'm making arguments. And you pussies, okay, can't make a real counter argument. All you can do is this psychobabble bullshit. And you think it's somehow, oh, I'm making very effective arguments by calling him a duty head. No, you're really not. But you're not explaining why I'm wrong. You're just saying I'm wrong. You know, it's pathetic. All right, extremely conceited. And you don't think Veritasium or whatever her name was, or Professor Lewin or any of these people are conceited? Degrassi Tyson, Mickey I Caillou, you know, whatever, Mickey Mouse you. These aren't conceited people? Oh, you're pathetic. Instead of approaching the situation as a constructive way. Well, the constructive way was I drew the pictures in the beginning of the video explaining what the actual facts are. Okay, and everything I said in that drawing was an actual fact. They're all factual statements that are factual circumstances. And all of those facts were completely ignored by the video presenter. The science presenter was ignoring all of those facts, okay, in presenting her argument. So it's like somebody, a lawyer, ignoring the gun on the table and the knife and the credit card and the fingerprints and the DNA and just arguing, well, look, he knows how to tie his shoes. How could a person who knows how to tie their shoes be a mass murderer? That couldn't possibly be true. Could it? Yeah, it's really that bad. I mean, physics is so off the evidence cart. Okay, there's just no point, right? All right, a huge part of learning, this is not just so special. Learning, is that what you call it when you're making an argument to a jury? Is learning? No, you're making an argument, and the argument is to persuade. And what should persuade people? Facts are bullshit. And what you're proving is that you are the idiocracy. You are the crowd for the professional wrestling. I don't care that it's fake. I don't care that it's overtly a soap opera. I don't care that I'm completely being manipulated by a complete fake drama. Because I'm a child, and I can't do any better than that. You're an idiot. You're what's wrong with the world. You're a little follower. You're so pathetically sheeple. All right, a huge part of learning is communication and collaboration. What does collaboration have to do with it? So again, who did Newton collaborate with? Oh, that's right, absolutely no one. The greatest physicist in really history, right? And all of the others, Descartes and Galileo, none of them were partnered with anybody. So what a pile of crap. Okay, anyway. And you successfully managed to do both of these things horribly. Yes, exactly. Well, the communication thing, I would argue I'm doing just fine. I present the arguments, I draw them, they're really simple to follow. Now, will you explain how a lever works? It's not very complicated. Explain how levers are free energy devices, because that's what the kinetic energy formula says. Explain how a syringe, right? Something as simple as a syringe, okay, is a free energy device. all I do is connect 2 of these syringes to a 10-ton train going 5 miles an hour, and have the other one with a hose on it to one single syringe, and I can create a 5-ton train going 10 miles an hour, and that will have twice as much energy. So with something as simple as a syringe, I can create free energy and save everybody from all of the horrible expenses, okay? Free cars, free heat, free cooking, free everything. That's what you're defending. That's the idiocracy you're defending. They're proposing a silly, preposterous theory, okay, that there's free energy, and you're believing it and supporting it. Because you're an idiot and a jerk. Okay, anyway. All right. Be happy that people are interested in science. Well, interested in religion isn't something that's going to make me happy. They're not interested in science. Science requires evidence, and it requires, like, repeating the Eddington experiment. It requires actually waiting for evidence to show up before you draw a conclusion. It requires you to prove a case. That's what's supposed to happen at a trial. You don't show up at court and say, "Isn't that guy creepy looking? Look, he's black. He must be guilty, right?" You don't do that. No, you actually prove that the individual committed the crime. And science isn't doing that. Science is a dogmatic religion. All right. And find ways to make your content better. Yeah, well, the point is if better means it has more dirty diapers in it, it's not going to happen, okay? If I have to talk gooey crap to you retards, that ain't going to happen. I'm not going to say, "Oh, you're so special. You're so pretty. Oh, you're so charming and interesting. Oh, yeah, I love that video game too." Yeah, no, I'm not going to do any of that shit, asshole. Anyway, better to effectively correct this so-called misinformation. We know you can't do it that way. The only way it's going to happen is that enough people have to say no. Because we already know you're just a sheeple Borg, okay? The fact that you've had a wrong kinetic energy theory for 300 fucking years is just evidence that you all have the mind of sheep. You can't think. You can't evaluate. The fact that she could title a video "Double Slit Experiment" when the double slit isn't explained in the experiment should just be so glaring to you idiots that, that should be illegal. That should be the thing you punish. That should be where you type a comment and say, you really shouldn't put double slit in the frickin' title when you're really not going to explain the actual double slit experiment. Anyway, to a larger group of people. It's honestly hard to sit here and listen to your voice. Yes, I have the same problem. I hate listening to your videos, no doubt. I mean, it's a good thing that they're 15 seconds long because, who could stand it? You're trivial and stupid and idiotic logic. But yes, I struggle to watch any of these videos online because they're such a slander against good science. They're a slander against the facts. They're a slander against the truth. It's like listening to some lying preacher talk about how many times, how saved we are by Jesus or something. How he did us all such a great favor and that things are so much better than they would be if he didn't save us. I mean, just recognize that the plague happened after Jesus was supposed to have saved us. Okay. And what you have to say while typing this comment: holy, period. Yeah, okay. See, even reading that is annoying. What the fuck does that even mean? Holy. What does that mean? Oh, so anyway. But yes, I find you repugnant and nauseating. So, yes, we should have comparably negative sensations. Just like, manatees sitting down at the table with, bluebirds. They probably aren't going to sit at the same table and say, "Gee, I find this so charming." No, they're not going to be charmed. So, yeah, I find you repugnant and evil, even. You are the reason the world sucks. Asshole, stupid fucks like you. Stupid, sheeple-brained defenders of idiocracy and lies and sloppiness and cheats and all of that crap. Crap like you is why the world sucks. The world wouldn't suck if assholes like you didn't defend the suck. You defenders of suck are really the problem. You're worse. Okay? Just like the fence walkers who just create a distraction and get in the way. You know, you can't kill the enemy because the fence walkers are in the way. Ugh, you're a putrid pile of shit. Alright, so enough of that. Alright, so I think that's it, part 2. So I'll put it on YouTube just to save myself some work. And yeah, just say, okay, there won't be any counter arguments to any of the facts pointed out, because the fact is I have deconstructed the double slit experiment. I have revealed the truth, how it really works, and all the crap they're talking is just that crap. It isn't the truth, it isn't the facts, it isn't the way it works, it isn't a mechanically sensible explanation, it isn't good detective work. I've done the good detective work, they did the sloppy one. I'm defending the right cause at trial, they're defending bullshit at trial. That's the fact. Okay. And nothing will change until you people force there to be a change. I can't make the world change. You, okay, have to do something about it. You have to force them to answer the questions. You have to force them to respond to the critiques. And until you do that, nothing will change. It's the way it works, unfortunately. Alright, so this has been a draftphysics.com, debatephysics.com also. But again, you can't debate cowards. You can't debate lawyers who won't pay any attention to the evidence on the table and debate the evidence. Can't do anything. They got to play by the rules or there's no game to play. Just a fact.